Hello, my name is Vaishnavi Perka. Me with my teammate Vyshnavi Priya Kasarla from Group 16 worked on the project AI for early detection of fetal abnormalities. This work focuses on how artificial intelligence can support early diagnosis during pregnancy using a multimodal approach. Fetal abnormalities like brain malformation or heart rhythm disorders are often missed during early pregnancy. Traditional tools such as ECG and ultrasound depend heavily on the experience of clinician and their effectiveness vary. Our goal is to build a multimodal AI system that integrates both imaging and heart signal data, offering accurate and real-time diagnosis. Even though we have current methods, they have their own limitations. Existing AI solutions are usually built around the one data type, either ultrasound or ECG, but not both. This limits the ability to detect complex issues that involve multiple systems. There's also a technical gap. Current systems do not integrate spatial features from ultrasound with temporal patterns from ECG, which is crucial for full diagnosis. On top of that, many models don't offer explainable results, which makes clinical adoption harder. So, we set out to address all these points in our work. Our motivation was to build a multimodal AI system that reflects how doctors actually diagnose in practice by looking at both imaging and heart signal data together. Before building our model, we explored related work. The Sonio suspect system, recently cleared by the FDA, improved anomaly detection by 22% using ultrasound alone. Sense used VNet for head segmentation with 86% accuracy. The Light GBM model achieved over 98% of accuracy using ECG data alone, and our own model, called Fusion AI, combines both ultrasound and ECG using a three-part architecture, ResNet 18 by LSTM and Fusion Neural Network. With this, we achieved an F1 score of 0.9722 and accuracy of 96.46 and recall 100%, which means that our system is not just smart but also robust and clinically usable. The main purpose of our model is to build an AI based system which first detects the brain abnormality and then cardiac rhythm anomaly detection and finally integrate the results from both of the models and build a fusion model to detect fetal abnormalities. For the data, we referred various resources. For ultrasound image data, we took two datasets. The first one is from Roboflow for the training, and the second is from the Kaggle for generalization and testing. And for the fetal ECG signal data, we referred PhysioNet by applying few processing techniques like filtering, normalization, augmentation, time domain features, and frequency features. So let's look into each of the models separately and then integrate both the results to build a multimodal system.
So let me dive through the models which we have used in our project. The first one is ultrasound model. Uh, in this, we have used ResNet 18, which is a deep convolution neural network, which performs very well on the medical images. So, firstly, we'll give input as grayscale image, and the trained model will classify the key fetal brain structures as CSP and LV, and this will be classified as a abnormal or normal fetal. So this is the example diagnosis report for the fetal image. So this is a GradCam visualization. This shows up which part of the ultrasound image the AI model focused on to make its prediction. So here the CSP score is 0.94 and LV is 0.96, which is beyond the threshold. So this image is classified as a abnormal fetal image. Model is ECG. This is designed to detect the fetal arrhythmias, which are irregular heartbeats from the abdominal ECG signals. In this, firstly we'll take the input as 10 seconds 4-channel fetal ECG segment. And this architecture has two main parts. The first one is 1D CNN, which extracts the local waveform patterns. things like the shape of the QRS, complex P waves, T waves, etc. And second one is bidirectional LSTM models. The heartbeat rhythm over time, like it captures the directional rhythm patterns and sequences of the heartbeat. And finally, this model will classify whether the ECG given input ECG is normal or abnormal. And coming to the final model, this is the fusion model. Here, we bring the both models result together. So this model doesn't take the raw images or signals. Instead, it uses the output scores from the previous two models. So here, the input features we take CSP abnormality score, LV abnormality score, ECG normal probabilities, and abnormal probabilities. So the model architecture is very simple. Like it takes the four inputs, the hidden layers with 16 neurons and dropouts, and the output nodes with softmax activation function classify whether the uh, fetus is normal or abnormal. So let me show you the already pre-run codes for all three models. This is the ultrasound model. This is the main structure architecture for the ResNet 18. This is the GradCam visualization for a single image input. This is the metrics for the ultrasound model for both labels CSP and LV. And next ECG model, uh, where we have used the main architecture of CNN and Bi-LSTM model. Here comes the metrics for this ECG model. The accuracy is 98%. So this is the fusion model. This is the example diagnosis for ECG and ultrasound data. So the fusion model generates the uh, values for the CSP, LV, and ECG, and these values are less than the threshold. So the final diagnosis is declared as normal. This is how the final patient report will look like. This is the ultrasound image which we gave as input, and this is the abnormality scores. So to summarize our whole project, we have created a powerful practical AI system for early detection of the fetal abnormalities. It works by analyzing ultrasound images and ECG signals and fusing both outputs to make the reliable diagnosis. For future work, we want to use the maternal data like blood pressure and age, and we want to deploy uh, the real-time web-based interface. And also, we need to increase the model robustness across various data sets. These are the citations which we have referred. Thank you.